Hi guys, I'm Mr. Day and today we're going to use a quadrat to sample plants. So this is a quadrat, it's a square, and we're going to use it along a transect or random to sample our plants. So first I'm going to lay out a transect, and to do that I'm using a tape measure. So I've got to 7 meters this way, and transects are normally used from a point of interest. So I'm going to put down my quadrat at 2 meter intervals, and I'm going to count the amount of daffodils I have in my square. So at 4 meters, I have 1 daffodil plant inside my quadrat. So if we're measuring from a point of interest, we know that, say for example, we're under a tree. Under a tree there's lots of shades, there might not be as many flowers growing. And as we move further away from the tree, there'll be more flowers because there's more sunlight. So I've just measured the area here, which is 300 meters squared, so I can now randomly sample my area. So what I'm going to do is take my quadrat and I'm going to randomly place it somewhere, and I'm going to count my daffodils. So in my quadrat here I have 1, and I can work out the coordinate of here by measuring across and along my area. Choose another random place, pop it down there, and how many plants do I have? I have none. Let's do it again over here. So let's take a few steps this way. Okay, now I've got loads of plants here. So I'm going to count them up. 1, 2, 3, 4 plants in this area. So I can write that down in my table. So I've got my results here. We just measured the field, which was 15 by 20 meters, so 300 meters squared. I've randomly sampled and looked at the location of each of the flowers. So we were measuring daffodils, and I've written my results next to it there. So I've taken my measurements of flowers in my 5 different coordinates randomly sampled. So here we've got 7 and we've taken 5, so the average there is 1.4. So we know that there's 1.4 daffodil plants in each quarter meter squared area. So my quadrat is 50 centimeters by 50 centimeters, so the area inside will be a quarter of a meter, 0.25 meters. So if my field is 15 meters by 20 meters, I know that the area inside is 300 meters squared. And for every quarter of a meter squared, I have 1.4 daffodils. So I can work out how many quadrats I can fit in my area by doing 300 meters squared divided by the area of my quadrat, which is 0.25 meters squared, which gives me 1,200 quadrats in that area. So I know I have 1,200 quadrats will fit out there, and I know that 1.4 daffodils in each one, so I can do 1,200 quadrats times my 1.4 daffodils, which is 1,680 daffodils in my 15 by 20 meter area.
So Mr. Day and I discussed the fact that we need to be more accurate and we need to take more samples. Our school's amazing for litter. We have hardly any litter at lunchtime and break. It's amazing. We've got an environmental committee. They're doing a fantastic job. But we noticed chewing gum. And I wanted to see if we could put a case together to find out whether we can have this area washed, cleaned, or something like that. So I'm going to find out how much chewing gum is on this playground. And the area is 60 metres down length by 30 metres across. So that makes 1,800 metres squared, 1,800 metres squared. I must place these randomly. So I'm going to place mine randomly, and I'm going to check for, oh, shouldn't drop it, might break it. I'm going to check randomly for chewing gum. 1, 2, and here, 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 here, and here, here, and here. So, a playground is about 13 metres by 60 metres, like we said. So that will leave us with 1,800 metres squared. Like Mr. Day showed you, each quadrat is 0.5 metres by 0.5 metres. That will leave us with 0.25 metres squared. That means that if we get the 1,800 metres squared and divide it by how many of these quadrats we could get in there, that will give us 7,200 quadrats on that playground. I sampled loads, more than we did earlier, and that's the point of accuracy. The more I do, the closer I get to the real example. I had 1, I had 0, I had 2, I had 3, I had 4 once, that was a lot, I had a 0, I had a 1, I had a 2. There was one point where I had 5, it was quite a large one, and then there was a 2 and a 1, and a 1, we had a 0, and a couple of times we had a 0, then we had a 1. We also had 1 with 10, which was ridiculously high. So, adding all these together, all the way through, we get a total of 33. And we divide that by how many times? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How many times we did it? That gives us an average of, rounded to the nearest whole number, 2. That means that every quadrat has an average number of 2 pieces of chewing gum per quadrat laid in exactly every place on that playground. So I know that there were 7,200 quadrats laid side by side on that playground. They would fit in that position. So 7,200 would fit in that area. Now, if I know that, and I know that every one is probably going to have 2 pieces of chewing gum in, I'm going to times that by 2. That'll give us 14,400 pieces of chewing gum on that playground. I think that's a case to get it washed. Do you? As you know, that's a lot of chewing gum. We can make this more accurate. The more samples we put in this position, the more accurate we get. We could even make it perfect by sampling every single square, but that would take us forever. So this is always going to be an estimate, but it's a good estimate, and it's as close as we can get. So transect is a different type of sampling. Now we're not looking for random numbers now. I'm going to look to see if this tree affects what grows underneath it. So I'm going to measure from the tree outwards, as far as I can go, until there's going to be very little impact from the tree. Let's say there was something living down here, daisies for example. Probably the wrong time of year to have a go at this, but I can take a sample every metre, count what is in that, every single metre I go along. At this time of year we can see that there's a lot less vegetation under the tree than there is away from the tree. So this grass is obviously crying out for some sunlight for photosynthesis, and therefore under the tree less is going to grow. So I could use this probably at a seaside, from the edge of the sea into sand dunes, maybe towards land, and see if anything grows closer to the sea or further away. From our tree, I'm going to create some samples every metre, probably 0, we'll have a look at 0 as well, 2, 3, 4, 5, and this can show us interesting things about anything that lives further away from the tree, using the tree maybe as a form of nutrition, maybe using the tree as a shade, maybe using the tree in a different way. Probably going to outcompete most flowers or most vegetation for basics like sunlight and water. To make that study probably just a little bit more accurate, you could have closer spaced transect samples, or maybe even have more samples over the distance.
Yummy.
Thanks to Mr. Day for helping with this video. Thanks for watching. Don't forget, subscribe. I'm only joking. Are you ready? It's not 180. You filming? Here!
Oh wait, I didn't. I think I pressed it a bit late. Wait!
Could get in there. That'll give us 72,000.
7,200. If you just times it up by 4, innit?
Of course it is. And then like start from down there and go up to me. You ready? Okay. So I'm going to measure from the tree.
Let's see.
Yeah.
Is that for year 7? Is it? Oh, I'm recording.
Did that work?